Hey guys, how are you all doing? Hope everything's going well and you're staying safe and staying away from people and everything. So I guess it's official now that we won't be coming back to school. So I was looking forward to getting back and doing a little bit in the classroom, but I guess it's not going to happen, so we'll have to put it off till next year. So what I want to do here moving forward is hit the important things that we need if you're planning on moving forward to another math. Okay, so this is week 14. So as long as the weeks and everything are falling like they should still, that means that after this segment, we should have 4 more segments. So 15, 16, 17, and 18. I'll have to look at the calendar just to make sure there's not an extra one or anything like that. So what I'm planning on doing is hitting the important stuff that you'll need, because some of you, I'm sure, are planning on taking college algebra or pre-calc or whatever you're going to do next year. Okay, so we're really in pretty good shape. We'll just hit the important stuff here moving forward. So what we need to do is finish up our application with the law of sines and cosines here. So if you recall last week, we did application of the law of sines and cosines, but we did it using bearing. Okay, so we dug deep back into the stuff that we knew way back when we were in school. Remember, we did the tape on the floor and everything to learn the bearing. And then we were able to apply law of sines and cosines to it because our pictures didn't make right triangles. Okay, so that's the whole reason that we're using the law of sines and cosines. So today we're just going to do regular old application problems. So hopefully you get an idea of where you might actually be able to use some of this stuff if you happen upon a situation like any of these. And then it also helps you further your understanding of which law you should use and what gives you that what gives you the reason to be able to use that law. Okay, so look here at example 1. So this guy needs to measure all the way across the river. Obviously, he doesn't have a boat or anything that he can go across the river with a big tape measure or anything like that. So he's stuck with just figuring out some measurements on one side of the river and using a trig ratio or trig formula to get him over to the other side. So I don't like that they put their angles on the outside of this picture, so I'm going to write them inside. 112.9 degrees would be there. 31.1 degrees would be there. Okay, so now let's talk about what we're looking for. We're definitely looking for angle A here, or side A, sorry. Okay, that's the one that we're shooting for. So we need to figure out some kind of situation that has that in it. Now, let's talk about what formula we should use. Can we use the law of sines? In order to be able to use the law of sines, we have to find a control. And by control, I mean an angle and a side opposite of it that we have, that are given to us. Okay, so that's our go-to when we're trying to figure out which law we should be using, is to decide if we have a control and if we can come up with one. Okay, so the cool thing about this picture is, any picture for that matter, anyone that gives you 2 angles, you can automatically come up with a third, because you know that there's 180 degrees in a triangle. If I want to subtract 112.9 and 31.1, that's going to give me 36. Okay, so I automatically have all the angles inside this triangle. Okay, now what you notice is I have a control, because I have 36 degrees, which is an angle inside the triangle, and I have 347.6, that's actually supposed to say feet after it. Looks like I cut it off. Okay, so I have that control, so I can automatically know that I can use the law of sines. If I can't come up with a control like that, I've got to use the law of cosines. So I'm going to set it up using that. I'm going to say sine of 36 over 347.6 is equal to, now what side do I want to set this up for? Would it be useful to us at all to find this side over here, this, I almost said hypotenuse, but it's not a right triangle, the longest side, the one that goes diagonal across the river? No, because we're not interested in that. All we really want to know is the side A, so the one that goes straight across the river. So let's set up our trig ratio based off of that. So we'll say, whoop, I'm in red. We'll say sine of 31.1 over A. Okay. Now I've got to set up, and a few simple calculations are going to get me to the answer. Remember, in the law of sines, you cross multiply, so I would have A sine of 36 is equal to 347.6 sine of 31.1. And very quickly and easily, I can get A by itself, because I can divide by sine of 36. So I'll divide by sine of 36 on both sides. That leaves me with A here. And I'm just going to type the whole right side into my calculator. So 347.6 times the sine of 31.1. and then I will divide that by the sine of 36, which is 305.46. Let's look at the rounding up here in the original. It rounds it to 1 decimal place, so 305.46, let's round that to 305.5. And this is a distance, so we will call it feet. Okay. So as you can see, the calculations are actually very simple on this, and doing the math, and there's not much trig that you actually have to do after you've decided which law that you should use. So that's the main objective today, is to decide which law that you need to use and then be able to apply it based on the information that they give you in the picture. Let's take a look at another one. So here in example 2, this guy needs to figure out how far it would be through this mountain if he was going to put a tunnel in. Now, just picture yourself, you're building a tunnel, and you need to know basically how long your tunnel would have to be. There's no way that you're going to measure straight through the mountain or whatever you're building a tunnel through without, number one, building a tunnel or using some kind of trig to get you around the outside. Because you can't just run a tape measure over the top, and you can't just run one around the side and estimate it, okay? But what you can do is set up a situation like this, okay? So they've chosen a point C, and they've taken some measurements from that point C, and they're going to use trig to be able to find the distance through this tunnel, okay? So the tunnel is definitely what we're looking for. That's our x value, okay? So let's see if we can set up a control. Can we find a control? So the one angle that I have is 110 degrees, okay? So I only have one angle. That means I can't find the other two by just subtracting or anything. So 110 is across from x. I don't have a control there. 3800 is across from an angle I don't know, so I don't have a control there. 2900 is across from an angle that I don't know. I don't have a control there either. Could I use like the Pythagorean theorem to get x and then have a control because it would be across from 110? Well, no, because we don't have a right triangle. 110 gives that away, obviously, okay? So I'm going to be forced to use the law of cosines in this situation. So hopefully you were able to understand the reason why we chose sines on the last one and cosines on this one. It's all based on being able to find a control or not, okay? So also, if you remember about the law of cosines, there's like 3 different renditions for A's, B's, and C's, okay? And I talked about how you don't have to remember all those. You just have to remember where the things go. So let's apply that now, okay? We're going to be setting this up for x. So that's what we're solving for. The other side of the law of cosines is the two sides that you have squared added together. So 3800 squared plus 2900 squared. Then you subtract 2 times both those sides again, times the cosine, I almost wrote sine, of the angle in between them, okay, or of the angle across from what you're trying to solve for. Okay, so the cool thing is that whole right side right now is just a number. Okay, so I'm gonna find it out now. 3800 squared plus 2900 squared minus 2 times 3800 times 2900 times the cosine of 110. That gives me a big number. It's 30388,123.9589. Okay, that's x. That's not x, I'm sorry. That's x squared. Okay, we're not interested in x squared. So let's find x. In order to get x from x squared, I'll have to square root that number that I just got. I'm not writing it down because it's a big number. Okay, so I'm square rooting it in my calculator. It gives me 5512.5. So x equals 5512.5. What are we working with here? Meters? Okay, meters. All right, now, the rounding on this one gets a little weird because the 2 originals are rounded to the nearest hundreds, so technically you could round this to like 5500 if you wanted to. You could round it to 5512, 5513. Okay, I'm not interested in that. It doesn't matter to me. As long as you get to this point, you've got it figured out, and the rounding will make itself, it'll become apparent whenever it's necessary, okay? So we very quickly and easily found the answer to this after just understanding which law that we needed to use. Okay, so that's my whole objective today. Let me scroll this back out to where you can see both of them. That's my whole objective today, is that you'll understand which law that you should use in which situations. Okay, up in example 1, we used the law of sines because we could find a control. Down in example 2, we could not use the law of sines because we could not find a control. Okay, so we reverted back to the law of cosines, which ended up being very easy for us. Okay, So hopefully you're good on this stuff. I'm gonna write the assignment here. Okay, we're gonna work on page 302. And don't stop the video yet because I want to say something after this. 33 and 34, and then 39 through 43. Got 2 pages again, like we did last week. 39 through 41 and 51 through 54. So here's what I want to tell you. On page 302, actually I think it's on page 303. Just a second, let me find it. There's going to be 2 problems that I can see you panicking on, and I know that you probably would panic. So let me just talk to you about them real quick. It's on 303. It's 41 and 42. One of them involves a cog, and one of them involves these atoms that they've got drawn here, and they're connected. But it's the same basic situation. Okay, so if you're looking at that page, you'll know what I'm talking about. You can find the side lengths to these triangles by taking into consideration the radius of each of the circles. Okay, so for instance on 41, if you wanted to find the side length that's straight up and down on the far left of that triangle, going from the center of the green cog down to the center of the pink cog, just take the radius of the green cog and the radius of the pink cog and add them together, and it gives you that side length. Same for going over from the pink to the blue. The radius of the pink plus the radius of the blue would be that side length. Okay, so understand that moving forward, or on those 2 problems, that's how you're going to find values in your pictures. Okay, so hopefully you're good to go on this stuff. If you have any questions, please let me know. You guys are either doing really well with them or you're looking up the answers on the internet or something, because I haven't had many questions. So just let me know if you need anything. I'm happy to help. I'll send you a video or a picture or whatever you need to explain it to you. Okay, so I'll see you guys at some point. I'm sure we're going to do something for the seniors, some kind of graduation or something in the summer, so I'm sure I'll see you then. I'm disappointed that we're not getting to come back to school, but it is what it is, and we've got to do what's best for us and everything. So just stay in, stay away from people, and be safe. Again, let me know if you got any questions. I'll see you.